Okay, so we're going to start doing the piping installation today. So let's just quickly look what we're going to do. So your tank on top of the roof, where the collectors fits in, if you cut through it in section, it looks something like this. There's a hole for the element to fit, so we're going to fit the element. Then on top there's two openings, and at the bottom there's two openings. Now you can't interchangeably use these openings because it has got some consequences. So one of the openings on the top actually has got a pipe in it that flows deeper into the tank. This connection needs to be connected to your feeder tank. In essence, what's going to happen is the other connection on the feeder tank is going to go to the water mains, and then there's another connector, and that will be your overflow pipe that will be connected to it. So in essence, what happens is cold water comes in. As long as this and the big tank is not filled, the cold water will flow through. Remember, cold water will settle. So that's why my pipe goes down to the bottom. If I use this connector to actually put the cold water in, now I'm going to continuously pour cold water into the warm water. So that's not a very smart idea. Yeah. So the pipe that goes through to the bottom of the tank is the one that will feed the cold water. Now similarly, at the bottom of the tank there's two connections. In our case they are marked. One of them is marked in red and one of them is marked in blue. But when I had a look at my tank, the guys in the factory actually incorrectly put the little rubbers over the pipe. So make sure that the pipe that will feed your hot water out is the pipe that goes into the tank, because you want hot water out. If you use this one at the bottom, guess what's going to happen? You're going to get cold water out, because the cold water is at the bottom of the tank. Okay, so that's the connections to the physical tank. Now obviously we've got a current installation, and the current installation looks something like this. There's a water mains that goes into a pressure valve. This valve makes sure that the water that goes into the water heating system, which is an electric system at the moment, don't exceed the specification for that water heating system, so that the pressure is not too high. So it regulates the pressure, but it is under pressure. So the cold water will come in, it will be heated up by an element, and the hot water will go to the top. So there's a little connector at the top where the hot water is then fed to the tap in the bathroom or whatever. On top of here there's a little riser with a vacuum breaker. So if there is a vacuum anywhere in the system, that there's a place for that air to escape. Now our system is this new green one, so we've got water coming into the feeder tank, which has got that float valve that will then feed water into our tank, which the collectors will heat up, and the hot water we now need to feed into the pipe that runs to the bathroom. The problem is, if we just do this, we've basically got a low pressure feed and a high pressure feed. So if I switch this off, number one, so the electricity is not going to that element, the high pressure water will always take precedent. That's number one. Number two is, in essence, what we're basically doing is we're creating a high pressure feed into this low pressure water tank, which obviously this water tank was not built to do that, so we can't do that. So what we'll have to do is we'll have to break the connection here. So what I'm going to do is I'm going to cut the pipe and actually put a stop on there and just feed the warm water straight to the bathroom and kitchen of the flat. So the installation that we've done is on the roof of a granny flat. There's also a main house. What I'm going to do is I'm going to also put a T section in somewhere here, block it off, and if I'm happy with the pressure, I'll connect it to the rest of the house. Okay, so that's basically how all the pipes is going to work and fit. Okay, so what we've done is we've cut into the current water installation, and we've added a connection for our solar heating system. You'll see I've got two little ball valves there that I can use to cut the water off. So this is where we'll connect the water to, so the water from our water heating system and the water that will be used to supply the water heating system. Okay, so the first thing that we're quickly going to do is we're going to fit the electric element. This is a backup for if there's no sun. So you need to have a washer for this also. On the back there's a thermostat, so you can actually set it what temperature it needs to heat the water to. These two electrical connections, we'll talk about connecting it to the electricity later. And this then fits into a hole on the side of the tank. So just to make sure that it actually seals properly, I've taken some plumber's tape. So even though there's a washer, I'm still going to use some plumber's tape to make sure that we've got a good seal. The tool that I was talking about in the first video is a spanner to actually fit this with. I've tried to do it with a normal shifting spanner, but it's a little bit deep, so I had to go and buy one of these again because I couldn't find. So element, washer, hole, oh my, this thing doesn't fit. The spanner is too big. We've got a problem. Okay, I'll have to find another way of actually tightening this thing properly, because it is going to leak if I don't properly tighten. In this wall we basically opened up the pipes and created connections. So the wall more or less runs here, and now we need to bring those pipes up. So we have to bring them through the roof, but the cable is quite, or the pipes is actually quite thick. So what I'm going to do is I'm going to drill a pilot hole, and then I'm going to use a punch. So this thing is a punch to punch out a hole in the steel sheet. This is quite tough because it's a 6mm steel sheet. I hope I'll get through with a punch. Otherwise, lots of filing. Yeah, so what I'm doing at the moment, I'm trying to see where the outlets are. Okay, so that's more or less here. But I also know that I've got a beam running exactly here. So I'll have to make a hole. Let's see, relation to the beam. That's probably one on each side. Also, when you drill, don't drill in the gully, the low part of the sheet. Always do it on the top, because there's water that's going to flow here, so it's always easier to seal on top than it is to seal where the water is running. So even if you try and seal it here, it will always leak. And life, I'm going to punch it first. So I've made a little guide here with a punch. Hopefully it won't slip anymore. enough to know. Okay, this is the thickest drill that I can fit in this battery driven screwdriver, so I'm going to do something that you shouldn't. I'm going to just wiggle it a little bit and make the hole bigger. There we go. Okay. Down, and the bottom bolt I'll have to fit from underneath. That's enough. Nice, neat, round, big hole. Okay.
Okay, spanner kleiner. So Jan Hendrik was lucky enough to get a hole where there's two sheets of metal overlapping. So a little bit more work. It's always easier to pull towards you than it is to push away. My spanner is te groot. Maak hom kleiner.
Now you may say, why such a big hole for such a thin pipe? You see there's lots of play. What we need to do between the copper and the steel is to make sure that they're properly insulated. If copper and steel basically touches, it causes galvanic corrosion, and after a while your copper pipe will actually the oxidation on the copper pipe will sort of rust through. So the oxidation will actually make the pipe weak, and it may start to leak there.